Hey, what's going on, everyone? I'm out here at the school today. I figured I'd give you a quick little video on how to do your own triangulation. So I'm going to figure out from the backside of the parking lot how far away that Alberta flagpole is over there. So what you're going to need to do this is something to measure with. I'm going to use a meter stick because that's all I've got, but if you had a tape measure, that would be much better. And remember those protractors from the astrolabe activity? You're going to need one of those as well. So the first thing you'll want to do is pick out the spots you're going to use to mark your baseline. So I decided that if I use this spot marked by that stick and that spot over there marked by that stick, that if I were to draw a line between those two spots, that would be perpendicular to that Alberta flagpole over there. So I've marked off my two spots. First thing to do is measure out how long is your baseline. Hopefully I can speed this up for you a bit on the video because it's going to take a minute. But this is 1 meter. That would be 2 meters, 3, and so on. 17, 18, and almost exactly 19 meters. So that's going to be my baseline. If yours wasn't exact, don't worry about it. Your math will just work out a little bit differently. Next thing we're going to do is we are going to measure, okay, if this is 90 degrees, totally perpendicular, making a 90-degree angle that way, what is the angle to the flagpole right there? So what you're going to do is take out your protractor and set this so that 90 degrees is pointing perpendicular. Then hold it up and we can see, it's tough for you to actually see because my camera won't focus on two things at once, but if we were to hold this up, we're at about 15 degrees past where 90 would be, which means that if this is 90 and straight over here would be 0, we're like 15 degrees away from 90, so we have gone 75 degrees to get to right there. So we're going to keep that number in the back of our mind. We're going to go over to the other corner of our triangle. And same idea. If this is 0 and then this is 90, what is the angle to that flagpole? So I'm going to stand perpendicular again, hold my protractor up, and I see, again, it's tough because my camera won't focus on both at once. I'm going to say that that one's about 80 degrees. So let's go with that. So the numbers that I need to remember are 75 degrees, and I need to remember 80 degrees and 19 meters. We're on to the part where we actually need to do the math behind all of this. And so the tools you are going to need are your protractor and a ruler. Now you've got a ruler you can actually move around. I'm going to use these pictures. They're all the same size, so it'll work out just the same for me. First number I remember is that the distance between my two sticks was 19 meters. But I don't have a 19 meter wide smartboard. Your paper is definitely not 19 meters wide. So we need to come up with some kind of scale factor here. Scale I'm going to use is 1 meter equals 1 centimeter. But you may need to use a different scale depending on your numbers. So if I want to represent 19 meters using that scale, I need to draw something that is 19 centimeters long. So using my rulers, if I put stick number 1 at 0, stick number 2 should be at 19. And I'm going to put a straight line in between those two. And that is my baseline. So I'll label that as 19 centimeters. And then I'll get these rulers out of here. Next number that I remember is that the angle right here was 75 degrees. So I'm going to take my protractor down here, except 75 degrees isn't really an option. And I kind of glossed over this part in the video. Here's where I got that from. Because 75 degrees isn't what showed up on my protractor either. But if this is 90, and this is 90, and on the actual protractor, I measured that the number where we crossed through was 105. That means that in order for this to add up to 180 in total, if this much of it is 105, the rest of it must be 75. And so that's how I figured out that angle there is 75. But when I'm using this protractor, if I want to have a 75 degree angle, I'm actually going to need to draw it through 105, just like that. And so now what I'll do is I will take that line and I will extend it up as far as I can get it while still going through 105. So I zoomed way out. Let me check and see if I'm actually still on it. I am on pretty close. I'm at like 106. So let me just go like that. Now I should be right on 105. Next number I remember is that over here I measured 80 degrees. So I'm going to take a line and I'm going to draw it through 80, just like that. Now same thing, I'll extend it out as far as I can possibly get it to go. And it looks like I'm going to have an issue here where my two lines aren't actually connected. So what that means is I started my drawing too high up. I actually need to shift everything down so that I can get this all to fit on the page. If you're still having issues, what that means for you is that you didn't choose a big enough scale. So you're going to need to go back, change your scale. Maybe instead of 1 meter equals 2 centimeters, it's 2 meters. Sorry, 1 meter is 1 centimeter. Maybe that has to be 2 meters, taking up that amount of space, because that'll shrink everything down for you. But because I have this handy smartboard, I can just shift everything, and I can get it to look like that. Now I'm going to come down here and double check my angles. Oops. So on this one, I'm pretty close. I got to change that one a little bit. Let's go more like that. Now I'm right on 105. And then over here, I want it to be at 80. And yeah, I'm right on 80. So what this tells me is that where these two lines cross right here, that is where my flagpole is. So that was our Alberta flag that we were trying to triangulate to. What I get to do now is there's actually no more math involved. Well, just kidding. There's a tiny little bit more math involved. What I get to do now is I get to stack these rulers up. So I'm going to start with that one. And remember, these are all the same size ruler. So if you just use one ruler the whole time, you'll be good. So I'm basically just measuring what is this distance going straight down to the baseline from that top point up there. I'm lining them all up just right. I'm going to need one more, it looks like. And I'm getting that that total distance is 41 centimeters. So what I'm going to do with that number is I'm going to say, let's write it down. And then I remember that 1 centimeter on this scale diagram correlates to 1 meter in real life. So we can go back to October and use our formula where we have the scale factor equals the scale diagram over the original, we can say that our scale factor, if we were to get these two units to be the same, this is a reduction of 100 or an enlargement times 100, depending on which way you think about it. Easier way maybe to do this though is to just match up, okay, this is 41 times bigger. That means this also needs to be 41 times bigger, and kind of just use that proportional reasoning there. So what I can say after all of this is that the distance from where I was standing in the parking lot to that flagpole is 41 meters away. So I'm going to have to zoom out even more. And then I'll say that this total distance, which like if I were to try to measure with 41 meter sticks, would take forever, would be incredibly inaccurate, because you noticed I wasn't super accurate with where I placed the meter sticks. I would get an answer of 41 meters.